Okay, I hope everybody can see me. Hopefully, hear me, see me, hear me, see me. And if I look like I've gotten no sleep, it's because I've gotten no sleep. I've been it's just been crazy. This has been I think the first really good solar storm we've had in all of solar cycle 25. I think we had something decent in March, but I don't recall it lasting all that long, and it didn't give us nearly the kind of aurora that we got today, or over the last 24 hours. Um, Hi all. Oh, Mike Richardson. Thank you, Michael. Thank you so much for coming on. Michael is a moderator. When I do these live impromptu things, they get these notifications on their phone and they're like, "Oh, damn, where is she? Why is she doing this to me?" So, Michael, thank you so much for jumping on. I appreciate it very much, dropping everything and coming on and help moderating the chat. This is a totally impromptu thing. I hadn't really planned on doing it, but as the day has worn on and it's gotten more clear what's going on with the solar wind, I realized that there's a lot of misinformation out there. Plus, I was kind of going through the comments. I've been trying to catch up on comments for. Hi, everybody. I'm talking over you. I see a lot of stuff going on in the chat, and I promise to read it all. But what I was saying was that as I was kind of catching up with some comments and trying to see how everybody was handling all the news with what's going on with the solar storm, I saw that there were a lot of people who were very nervous and scared. I guess there's a lot of fear mongering going on, and I always hate that because I think it does a disservice to this field. For those of you who are nervous that the sky is falling, don't be nervous. This solar storm it's basically over. And that kind of makes me sad because I would have liked to have had another night of spectacular aurora like we had last night, but it doesn't look like that's going to be the case, and that's a bit frustrating to us scientists. Even though the aurora photographers are going, "Oh my goodness, who cares? It was wonderful." Us scientists are kind of going, because the solar storm, the configuration of it in the solar wind really was kind of ugly, and we didn't see the pretty coherent structure, the core of the structure that we wanted to see. So scientists aren't happy, and then it also means that it doesn't last as long as we were hoping. So if you're reading news articles about seeing the gorgeous aurora just like we had last night all over again, it's not going to happen. So just know that and spread the word, please, so that you don't have 1,000 people staring at the night sky going, "These space weather forecasters don't know what they're talking about. I don't see any aurora anywhere." Okay, so just spread the word that I think that the bulk of the storm is done, that the height of it was last night, and I'll get to that. Believe it or not, we do have another solar storm coming, but I think it's just going to graze Earth. I don't think it's going to hit Earth at all. Well, if it does, it's not going to be all that much, but it still may rattle Earth's shield because Earth's magnetic shield is already really rattled from what it's had to deal with over the past couple days. So anyway, okay. So I only have like 40 plus maybe 45 minutes to before I get kicked out of the studio. So I got to make sure I get to all this stuff for you all. So good to see you all. If I'm rude and not saying hello to each and every one of you, I am so sorry, but I see a lot of Patreon members in here. Remember, Patreon members, everybody be nice to the Patreon people because they are the reason why this forecast is even possible. This update is possible. And Patreon members, if you are not being heard in the chat and you're putting questions in and I'm not answering them, put them in the Patreon feed and I will answer them either live or later, and we can have a dialogue. So remember, you get the priority there. So just remember that. Okay, guys. So what I'm going to do is I guess I'll review what's going on and show you just really quickly what the new solar storm, at least what the new solar storm is all about. This is still at region 2882. Let me slide this off. Whoops, whoa, careful. I'm on a Mac, so it really is super sensitive. Let me stand on this side. This is region 2882 as it's rotating across the Earth-facing disk. And there was the big solar storm launch that was Earth-directed. Then you see a couple other things off to the west of it. And then as this thing continues to rotate, wait for it, boom, right there. That was yet another solar storm. That one is on its way, but it looks like it's going to go west of Earth. So we might get the grazing edge of it. It looks like it could be a flank grazing impact according to NASA, and I'll show you that in a second. But that will be late on the 15th into the 16th. But again, it doesn't take much at this stage because the Earth's magnetic shield is so rattled after this G2. It's so rattled that it won't take much to set it off, okay? But what we were trying to figure out as scientists is that you see all that stuff. There's the big one. Okay, my hand's in the way. Sorry. We'll probably wait for it to reset. But there was the big, right before the big M-class flare went off, there was a small thing, something little that went off. And we're trying to figure out if that was kind of the junk that we saw last night, and that maybe there's a bigger storm, you know, a kind of a jumble of this, like a big kind of traffic jam that hit Earth. But it doesn't look like it. So if I go here again, you can see the little one go. Did it already go? Maybe it already went. Oh, I let it go. I'm not paying attention. But we were thinking that maybe the small, maybe might have been a little small something, and then the big storm, and so maybe we were still going to see that. There was a small one right there, right before the big one. So there was all that little bit of mess kind of coming toward Earth. And you'll see when you look at the Space Weather Prediction Center, they've redone their model when they realized that the storm was going to be fashionably late. I don't know if anybody of you've seen this, but there's like half a dozen news articles out there that are adopting the term fashionably late, which you guys know is something I say all the time. And yes, they quote me. So if you're seeing news articles in the Daily Mail or the Australia Press or the news.au, there's all these articles coming out, and they're quoting fashionably late. So I think it's actually kind of cute that I've made the headlines in some of these articles because of that. But when they talk about new aurora or the big aurora possibilities lingering in through tonight, probably more at high latitudes than mid latitudes, folks. I think last night was the big show. And I can give you, for those of you who are not on Twitter and don't get the benefit of the nowcasting stuff, I might give you a few views of some of the amazing photos that are being circulated around on Twitter right now. It's just spectacular. We haven't had views like this in so long. Okay. So anyway, so here's that next one, right? This still from region 2882. This is this next storm will graze us late, right there, late on the 15th into the 16th. So just know that we might get a little bit more sporadic stuff kind of coming. We're also kind of in the middle of I don't want to say a fast wind stream, but it's a fast enough wind stream, a mediocre fast stream. So even though we won't see big aurora views down at mid latitudes like we did last night, we will still get some, let's say, some quieter but more green colors and more at high latitudes. So yes, Canada, you still have a chance. Yes, Sweden and Norway and Scotland, even, you guys still get more chances for aurora over the next couple days. It's just the people at lower latitudes that aren't going to fare so well this time. And I'm sorry, Europe, I know the storm hit too late for you and you got jilted. It was all the Western Hemisphere show, and I apologize for that. But you know, these things are as they are. Meanwhile, since I'm on the subject of the sun, where is it? There it is. I'll show you what's going on with stereo. It doesn't look like, you know, there's a lot more. Let me speed this up a bit. Doesn't look like there's a lot more going on when it comes to stereo. These are science grade images, so give it a second to catch up here. And then it's going to go really fast. When it goes to beacon, slow down, slow down. Okay, so we do have a coronal hole up here that was going to be that might give us a little bit of something in about maybe a week or so. But you know, we've kind of cleared out a little bit when it comes to the bright regions. We've got that one bright region up here in the north. Not a lot going on in the south, though. We just have a little bit more coronal holes. So that solar flux will eventually kind of tank a little bit. So amateur radio operators, you're going to have to deal with it. It looks like this week is you know, once we recover from that solar storm, things will be marginal, but then it'll get a little bit dicey. It's not going to go back to poor, but it's just not going to be great. And then it doesn't look like there's any solar storm players, so we're not going to get any big intense solar storms, but we do have some coronal holes that'll bring us some more fast wind. So it could give us, once again, more chances for aurora at high latitudes over the next week or so. But I don't see any big flare players, guys, so it looks like the excitement is going to be dying down for now after about the 15th. Okay, what do I want to show you? Let me show you this first. So this is what's going on with the solar storm right now. Okay, and this is why we're saying that things are not so hot anymore. Which side do I stand on? Okay, this side. All right, so if I can get this stupid cursor out of the way. So, okay, yes, it's a mess, right? A complete jumble, and I'm sure 90% of you don't you are overwhelmed by what this is. This is what we call a time series. This is actually data, what we call, it's basically solar wind data that contains the magnetic field and some of the plasma data, basically telling kind of like a weather instrument, like you'd have a barometer and an altimeter and all this and this stuff and a wind speed measurement for your terrestrial weather, right, for the air. Well, this is the same kind of thing for space. Okay, but what matters to us in space is the magnetic field components, which are basically the top 1, 2, 3 panels, and then we care about the speed, and in this case, actually the top 2 panels are magnetic field. My fault. And then we care about the speed, the density, and the temperature to a great degree, because it tells us kind of what the solar wind is comprised of. So that's what the 5 panels are. Okay, so just think of it as like a weather instrument in space for the things that matter to the Earth's magnetic shield. And then this is time that runs across this axis here. Okay, and the reason why we're only half populated is because according to this 3-day time scale, we haven't filled out this data yet. So as you can see near the front end of this, okay, this is where the solar storm hit. Do you see how everything goes up and suddenly goes and it gets all ratty? Yeah, that's the solar storm hitting right there. And why it was such a great storm is because you see how this line in red, okay? Do you see how up here, how this says 0? Where my hand is, it says 0 right there. I don't know if you can read it, but right where my hand is, you've got this horizontal line that goes across and it says 0. That is the delineation between a positive magnetic field in the northern direction or a negative magnetic field, meaning in the southern direction. Okay, this is positive, this is negative. To make the Earth's magnetic shield go crazy, you need negative magnetic field. That's the polarity. You need what we call a southward polarity. So anything that's less than 0 means aurora. And as you can see, this whole jumble of junk has been basically negative, has been, with a few, there's been a little bit here where the aurora turned off, and over here a little bit when the aurora turned off, where things went above 0. That red line went above 0. But for the most part, it's been pretty much what we call southward field. That means we've had really strong aurora. Plus, if I jump down to this panel, the yellow panel, this is the solar wind speed, just like a wind speed. It's analogous to that. So this tells you how fast this jumble of magnetic junk is brushing over Earth. Anything above 400 kilometers a second, you can see 400 is where my hand is right there. Anything above that means aurora possible, okay, basically. And as you can see, everything has been pretty much higher than that. And it still is. We're still sitting where that yellow line is. It's still higher than 400 kilometers a second. That's because we're now in some fast-ish solar wind. The difference, though, is that all that really intense, I mean, we're talking minus 15 on this scale. These are what we call nanotesla. Is down. That is actually kind of reduced. Now we're sitting almost at 0 when it comes to the southward, or the north-south magnetic field. So we really have turned off when it comes to aurora. I think we're through the storm. Why this upsets scientists is because there was no coherent structure in here. We were hoping for what we call a beautiful flux rope, and it would mean that the storm would last longer. It would mean that we were cutting through the center of this thing. It would mean lots more aurora and even much better predictors for us. We could actually forecast what the orientation of the magnetic field would be throughout the course of the storm. We got no such indicator in this time. It was very ratty. So that upsets us a little bit and makes us scratch our heads, because it was a gorgeous halo that came at us and we would have expected to have seen the core. But it also might have been a composite event. So at any rate, but it did give us some gorgeous aurora in multiple times in the United States, and then also I believe in the southern hemisphere. But the problem is, during the southern hemisphere, I think the aurora brightened a little bit too late. So the auroral oval had already turned away from Tasmania and New Zealand. So I don't know yet. I haven't gotten any confirmations yet if aurora was seen down there last night. I've been too busy to check. So my apologies for those of you. If you guys have seen it, please share with each other. If you're a field reporter in Australia or in New Zealand or Tassie, please let us know. I would love to hear it in the chat. I would love to have you guys spread the word. But sadly, again, I think aurora is pretty much petered out. So don't be out there looking for aurora at mid latitudes tonight. You're probably not going to see it. I just don't think that anything's strong enough. Some scientists may argue with me because they see this density being awfully high, but I don't think it's going to be strong enough. Okay, and yes, the storm arrived late. It didn't arrive on the 11th, it arrived on the 12th. So it was very late. So all of the agencies, there is a problem when the agencies want to be consistent with one another, right? So they all get on a phone and talk to each other and say, let's put out a consistent forecast. There is a problem with groupthink. It means that this type of thing happens and we don't do very well in our forecasts. I would almost rather see forecasts that are completely, different, that vary but wildly from one another. And have scientists in the loop stick to their guns instead of having everybody put out a coherent forecast that ends up being wrong for whatever reason. So we do need to get better at forecasting these things in terms of timing of arrival, but this is the state of the art, folks. I could show you the ACE magnetic field data. It's the same kind of thing. I don't think I'll bother you with that. It's even rattier in the ACE magnetic field data, which is another spacecraft that's kind of close to Discover, but it gives a slightly different configuration. But it just shows us that I don't think we pass through the core of this structure. For those of you who are, now this goes straight to those of you who are very concerned about this being a kill shot. No, not even close. Okay, this has been a very short storm. Like I said, we didn't go through the core. We think we went through the flank. That's why this storm didn't last that long. In the KP index, it's a stoplight chart, right? You guys know this. Green means good, yellow means red means storm. This was a KP of 5 at first. I'm standing on the numbers. Sorry. I probably should. I can make it bigger. Yeah, let me do that. And I'll stand on this. I'm still going to stand in the way. No, let me do it this way. Sorry, guys. Can't figure out what I'm doing. Okay. So KP of 5 is where the storm started. Very rapidly, within a few hours, it jumped up to KP of 6. We saw it was a KP of 6 in certain places, a KP of 6 as soon as it hit, because it was pretty intense. Just took Aurora a little while to build. But as you can see, it kind of bounced up and down from a KP of 6 to this is when the magnetic field turned. If I get my hand in the right place, it's when the magnetic field turned northward for a short while, and then of course it went strongly southward again, which gave us another 3-hour segment, give or take an hour or so, of solid, sustained strong southward magnetic field. Power grids don't necessarily like it when you're at a G2 level, which is what KP of 6 is, which are these two higher bars. But power grids don't mind too much if it doesn't last that long. And that's what we got here, guys. If this had been the whole plot was covered in KP of 6, right? If the whole, days and days of this, then I'd be stressed. I'd be worried. This is not anything that a power grid can't handle. So those of you who think that, oh my goodness, we're having power outages or my light bulbs are flickering and it's the solar storm, no, it's not. It really isn't. There are mitigating procedures that are in place for this. The NICT and the FERC have created these. Many scientists as well as engineers, the power grid engineers, have been working on these for ages. They know their grids quite well. They know how robust they are. So this is not a problem. And now things are going to even quiet down even more. So anyone who's nervous about it, please don't be nervous. Anybody who's listening to other YouTubers or any media out there that is scaremongering, just laugh it off, because this kind of solar storm is a very typical solar storm. We're going to be seeing a lot more of these. Okay, I don't want people to be having heart palpitations every time they see a G2 level solar storm. They're fun. This is why I get excited about them, because they're fun. You get aurora, you get great shows. I get to stay up all night and get no sleep. Or I get to have ham radio operators yell at me or then celebrate because they got to work, 10,000 miles, on 5 skips using auroral propagation at 10 meters or something. It's a fun time most of the time. Okay. And that's what this level of solar storm is. So please, those of you who are trying to say that I am being cavalier and not very nice to people, or not very nice because the world is going to end and I seem to be nonplussed, well, it's because the world wasn't going to end. And a lot of people were going to get gorgeous aurora shots Like, by the way, let me reload this. It's a perfect segue. They were going to get gorgeous aurora shots, just like this one. This is Dave McComb. And do you see what I wrote? Huh? I said, one of the reasons I forecast aurora are for moments like these. Magical views in the skies over British Columbia during the height of the solar storm. Thanks for reporting the stunning and romantic capture. I, for one, envy you both. And it's true. This is why I do this, guys. Look at this. Why? Who wouldn't, right? Who wouldn't want to get excited about this? This is what solar storms, when solar storms happen, a lot of the times this is what you should envision, okay? Not that the sky is falling, but that our Mother Earth is protecting us in a most glorious manner, and we should celebrate that. Mother Earth has been doing this long before any of us were ever born, and will continue long after we're all gone. So, okay. Now, for those of you who are interested in knowing how are the solar storm, how is it doing if you're at high latitudes, here's the AE index. Can I stand on this side? I don't know. Let's see. No, I'm going to stand over the numbers. I don't like standing on this side because I can't see what I'm doing. I guess I could use this frame. Okay. So the AE index really, these are related indices. Okay, it's like a family of indices. You have the upper index, the lower index. That's what the AU and the AL, it means for auroral electrojet, the upper auroral electrojet, lower. And they're just magnetometers. We're basically measuring how the Earth's magnetic field wiggles. Any of you who've seen my mini courses know a little bit about this. For all practical purposes, the easiest one to use is the AE index, which is the upper line down below. Okay, it's this upper line. And basically what the AE index is taking the AU, and subtracting off the AL. Okay, and getting the difference between the two and seeing how much the two are wiggling relative to one another. It's essentially what that is. Scientists in the room, don't get mad at me because I'm not being specific enough. It's close enough. Just know that it uses these two indices to come down to a third one. Rule of thumb, and I got this from a very savvy, from physicist Joe Fennell, Dr. Joe Fennell from the Aerospace Corporation, who's a very, very savvy magnetospheric physicist, and so I take it as gospel. The rule of thumb is that if you get AE at plus or minus 500, okay, so this bottom index, plus or minus 500, anything over that means aurora is visible, okay, especially at high latitudes. It's a really good high latitude index. So you can see AE can get blown out. See how this is actually off charts. That's because at high latitudes during this period, boy, aurora was just going crazy. But as you can see now, we really are getting to the point where we're not even getting substorms anymore. Like this little guy was just probably one of the last ones, and it barely peaked over. So right now, things are kind of on the quiet side, okay? And likely we're going to continue at this level, maybe until late on the 15th when that other storm sideswipes us, okay? So again, do not expect to get a lot of aurora. High latitude people, you'll be getting some, but you're not going to get the shows that you saw the other night. Okay, you're not going to get the storm time, the red auroras and the rainbow auroras like we got. You're probably going to go back to quiet green arcs. Probably will not fill the sky, sadly. So just know that last night was the height. But if you ever need to look at the AE index, look for AE index on Google in real time. It's a great place to get information. Okay, I know I'm jumping around a little bit. What I'm going to do now, because I don't have that much time, what I'm going to do now is I'm going to play for you. This is the current Space Weather Prediction Center model. They have, let me back off a little. They have rerun it. So they've done it a little bit differently now. Now when you look at this, okay, so again, this is the top panel is density, the bottom panel is velocity. And here's that solar storm coming out right here. Okay, whoops, this guy right here. Oh, come on, hands. I look like a drunken sailor. There's the thing. Now it looks like they've got multiple eruptions that are kind of smashing into one another. And I do believe they have the other eruption. They may have that other eruption in there. Well, maybe not. No, because that one's not coming until the 16th. So they don't have it. So they may redo this and have that next eruption because it's going to graze Earth. So there may be an update to this here coming out in the next day or two. But they did redo this forecast so that you can see it's a much less intense hit. It happens now on the 12th, and it looks like it's still going to be kind of dying off for the next day. Yeah, okay, that works. But the reason why I wanted to show this to you is because as you continue watching, that is the only solar storm they have. This little blip, which I'm stopping on right now, so back in time series, so you can see that there's this other secondary, oh, come on, Tam, get your hand in the right place. This secondary blip here that happens between the 15th and the 16th, that is not the new solar storm. Okay, that's not the one that was launched from the sun. That is simply a fast wind stream. Okay, that's simply the pinwheel, the arm of a fast wind stream. Okay, so this is a density spike from that. Do not get them confused. Okay, this is just ambient solar wind in a fast wind stream. When you push fast wind against slow wind, it compresses the wind in front of it and makes it like a wave, and that's what you're seeing. And sure enough, you actually see that borne out here as well, because you see right here, see that speed goes up. This top panel is speed at Earth. So that's what that is. Okay, that's not just a fast wind stream. If I flip over to NASA's version of Enlil, you see something different. This is actually an eruption. Okay, so again, you're looking down at the sun from the North Pole. Earth is off to the right. It's the yellow. There you go. That's Earth. Okay, and you can see that solar storm being launched to the west. Okay, that solar storm, and if I grab my freeze frame, there we go. I'll make it big. I just grabbed a quick screenshot. Hope you don't mind. If I just to get the timing when this arm, according to NASA, is going to sideswipe Earth, you can see sideswipe Earth just slightly. Sorry, I don't have it annotated, but I just picked it out and didn't have time. That time is shown here at UTC as basically late. Oops, I'm showing the wrong time. Here we go. The actual time is 1800 on the 15th. Okay, so October 15th at around 1800 UTC. So we could get a little extra something. And if you take a look at the footprint, sure enough, here's Earth. And wherever you see the black and the red, see all that? So we're going to get a side swipe. Okay, that's Earth. And you can see this kind of mess up here. That's the solar storm hitting. So could that bump us back up to storm levels? Yes. Why? Because we don't need, at this point with the Earth being so rattled, we don't need a big hit, okay, for that to happen. Do I expect it to last long? No, I don't. And I don't necessarily know if it's going to bring us any aurora down to mid-latitudes. If it does, it'll probably be fleeting. Okay, so not too much there. So what I'd like to do also is kind of show you a little bit about what's going on now. Sadly, I did not capture the I didn't do that. The geoelectric and geomagnetic fields at Earth while we were in the middle of the G2, but I am capturing, I did capture it earlier today. I want to play this for you just so that those of you who don't believe me when I say the power grids are fine, the power grids are fine, okay? And I should have grabbed, and if I have time, I might actually grab the 1989 event to compare. You have to have an electric field that's in the thousands, okay, in order to have, thousands of millivolts. So basically volts per meter, like 20 volts per meter, let's say, in order to have a grid, anything like a grid collapse. This was today, okay, just a few hours ago, and I'll pause it on the worst of the worst so you can see that we're nowhere near. Okay, never does this go to even 1,000. There's one point at which it gets close, and I'll slide back. And I'll tell you what this is in a minute. I realize I didn't even go over what the heck this is. People are looking at me going, what is this? There's a bad one. Okay, let's just freeze it there for a sec. This was back at 1800 UT today. Okay, so a few hours ago. Yes, we have come down from the G2, so this isn't as intense as it was, but it still was reasonably intense. So it tells you that this really wasn't so bad. What you're looking at is the electric field that's being driven in the ground, okay, that ends up coupling up into into power lines, transmission lines for national grids, okay, and why you get certain parts of the country that are far more, susceptible than, let's say, other parts, because red and green are hotter, they're higher values than blue. Okay, so people in California, for example, are doing just great, where people up in, the Michigan and the Great Lakes area, and then on the eastern seaboard or the East Coast aren't so great. This is because of the actual conductivity of the ground, right? The basalt, the bedrock. Okay, it changes, and some rock is better conducting than others. So magnetic field, with the earth wiggling, it can induce currents in the ground that much easier in certain types of rock than in others. Okay, so that's why these areas are much more susceptible. The reason why all this is black down here is because there's no data here yet. Okay, they're still mapping, they're still doing the geological survey. This is going to probably take another year plus to finish, but they're getting better. At any rate, this is kind of gives you a feel for whether or not power grids might be affected. Okay, this G2, not only do you have to have things that are in the volt level, not millivolts, so you have to have thousands of volts before you start getting nervous, but it also needs to be sustained. And as you can watch, this is all on, off, on, off, on, off. Okay, up, down, up, down, up, down. You're not seeing beat red for hours upon hours upon hours. That is when you start worrying about power grids. Okay, we're not anywhere near. So again, this is why I'm okay to get excited about these solar storms, because these types of solar storms are minor inconveniences, nuisances, not something catastrophic. Now, what's going to be fun, and I know I'm not taking any questions, but I want to make sure I get through this. What's going to be fun, do I want to do this first? Debating, do I do the neutral atmosphere or do the ionosphere? Charged layer or not? Yeah, let me do the charged layer first, because I'll save one of the fun things for last, speculative stuff for last. Okay, so what this is, I don't know if you guys know this data product. I am still learning the data product, so I'm not that good at it. I'm going to mention just momentarily about this because of ham radio, okay? What you're looking at is total electron content in the blue over here, then MUF, this is maximum usable frequency in this panel, and then basically the anomaly. This means the difference from the average, and the average in this case is a running average, a 10-day running average. So basically, what was it like on average the 10 days prior? And you'll see this is the difference. You're either really different is in one way in higher frequencies is red, different in low frequencies, meaning that the low frequencies are lower, is in blue. So those of you ham radio operators who are used to MUF, one thing I wanted to point out to you that you'll be seeing over the next couple days, because this is, notice it's October 12th, and it's going to continue into the future. So now we're beginning to get into the future. What I want to show you is, I'll stop right here. As we move into the 13th, this yellow at low latitudes is what we call the equatorial anomaly. It means MUF can be a lot higher, but it also means you have problems with transhemispheric propagation. It can oftentimes stop it, okay, for those of you on multiple, and this is on many frequencies. This layer, okay, you can't really see it because I don't know why they don't put the gray line on this map, but here's the gray line's kind of here. Here's where nighttime, whoops, come on hands. Here's where nighttime is. Okay, I'm trying to make myself the Terminator. Okay, so it kind of goes like this. Okay, can you kind of see that Terminator right about here? Look at this equatorial anomaly. It's all the way on the night side. Okay, so through the entire evening, right? So all your 80 meters, your 60 meters, your 100 and whatever meters, your top bands, they may be disturbed if you're trying to do even gray line, if you're trying to do gray line propagation or nighttime propagation. You may have issues with this, okay, over the next couple of days before things settle down. And you can even see it in the anomaly. Way big red, meaning higher frequencies are being used. Okay, so your top bands may not be as usable over the next couple of days if this thing is good. See, then things settle back down a little bit over the next few days. right? You're still seeing red, but it's not quite so bad. We go through nighttime here. I'll stop again at nighttime, almost the same period. Again, here's the equatorial anomaly, whoops, during the nighttime, at the near the pre-dawn hours. Not quite as robust yellow bands. So it is beginning to settle down, but expect that kind of slow dissipation over the next few days, okay? So things may not be, as far as radio propagation, may not be exactly what you expect them to be over the next couple days before things kind of go back to normal. Here's the other thing. Now, this is the speculative part that's really fun for me. Starlink, right? Low in Earth orbiting satellites. This is the neutral atmosphere. And that's one of the other cool things that this particular model takes into account. And what we're going to look at for the moment, is neutral density. Okay, I'm not going to worry about the O to N2 ratio. That's it's related, but it's a little bit different. But the neutral density here, we're basically talking about what happens with the lower atmosphere, how it inflates out. The Earth's atmosphere inflates outward when there's a big geomagnetic storm, and the G2 level is a pretty good example of that. And I said, well, let me just see what the neutral atmosphere is doing. And I was like, oh my goodness, compared to normal, this is really puffed out. It's not supposed to be red. Typically, this is like blue, or just at least not quite so intense. And you can tell that because this is the neutral density anomaly, okay? 100% higher is all red. 100% lower than average is all blue. Again, a 10-day running average. So right now, as I play this, because this is October 12th, I got the time sitting behind me. Look at this over today, and then it takes till the beginning of the 13th to kind of normalize. See how the anomaly goes away? Now watch it turn blue. Now what's happening is that it's shrinking. So the atmosphere inflates and then it shrinks a little. And part of that also has to do with the 10-day running average. It's biasing the data. So I can't say it's waving too much, but that's what you're seeing, is that what happens is that you have this atmosphere that inflates a bit, but when it inflates, what happens is that all the low Earth orbiting satellites feel extra drag because the atmosphere is thicker up there now suddenly. By a lot, by 100% or so. That's 2 orders of magnitude, okay? So while we deal with this over the next 24 to 48 hours, I'm going to be paying attention to the Starlink satellites to see if any of them look like they're falling out of the sky a little bit. Especially the ones sitting at about 450 kilometers, and see if they get a little bit lower, or some that are just barely hanging on to being able to fly, end up being pulled down and pulled out of commission. It's not that big a deal because this storm didn't last very long, but imagine if the storm had lasted longer. Okay, so that's, and notice in the neutral density, notice where you see the atmosphere getting really, really hot, heated. Okay, it's in the auroral zones. See, real high latitudes, right? Because that's where the heating's happening, because that's where the aurora is. So that all couples in. Neat, huh? So this is the thing that we have to worry about with all these constellations going up in low Earth orbit. A lot of the work is still speculative. We really don't know. But if you're worried about, is the sky falling? Well, maybe some Starlink satellites might, especially when the storms get big. But we don't know yet. It's going to be interesting. It's going to be definitely an interesting ride as time goes on. Okay, so that's all I have. I will take questions for about maybe 3 minutes. I think I maybe have 5 minutes to answer questions. Let me take a look in Patreon to see if anyone has posted questions there, because that's the most important to me, because that is the community who has kept me going, and I'm so grateful to them. Oh, thank you, Mike. You're standing by. Got the notice early. Thanks, Phil. So glad that you're here. Mike Essex, thank you so much. And Bart, you just got my email a few minutes ago. I love it. So you all are here. Thank you all so much for being here. You guys are just wonderful. And if others that are not in Patreon want to come into Patreon, it's not a hard thing. Just come on in, and there's all sorts of different ways. You can even just follow me, and sometimes I'll post stuff that even people who are just following me and just lurkers can get access to. So we're a real friendly community, I promise. Okay, so Kim, my husband and I have been incredibly in sync today. That's good. Maybe it's because of that other picture I gave. Oh, and let me do that too. Let me go back to that for a sec, so you guys can see. I'm glad you did that. You reminded me. Yeah, I'm not going to talk about spacecraft charging. We can talk about that later. It's mostly been just space weather. Let me just do pictures for the moment. So this is some shots. This was Deb Maluk in oh my goodness, Deb, in Manitoba. We've got Kim also in Manitoba. Here is some amazing stuff. This is with Vincent. I believe, I forget where this is. Where are you, Justin? I forget where you are. Oh, poop. Are you not? I don't think he's in North Dakota, but we've seen it in North Dakota, in South Dakota. We've seen it in Seattle. Here's British Columbia again. Here is Central Canadian prairies. Where are you? Oh, in Saskatoon, Saskatchewan. Here's some gorgeous stuff in Alberta. I'm going to try to get to, like, I've been retweeting like crazy. A lot of the really great ones are from are in Canada, but here's Seattle. And I'll see if I can answer questions while we deal with this. Would the storm be strong enough to interfere with aviation? Probably not this storm. Not this storm. Yeah, I've got a few minutes. Okay, I got just a couple minutes. Your UHF all-star node transmitted all by itself yesterday when the storm started. Yeah, you know that it's interesting with HF radio. I've seen people have actually gotten shocked. Usually it takes like a G3 level storm for people to get shocked, and for real, some type of electrostatic things happening that I don't think we understand all that well. But that for some reason that doesn't surprise me. All right, do I think the storm will last an hour in Nova Scotia? In Nova Scotia, you can try, because the things are still dying down, and you're far enough north that you might get a little something. But you're not going to get anything like you did last night, and it'll definitely be sporadic. Good for 50 megahertz e-skip. Right now, I think everything is probably, it's really dicey. You can try, but nothing is stable. As you saw, the atmosphere is puffing out and retracting and puffing out again. It's kind of ringing like a bell. So those ionospheric layers are definitely kind of think of like cirrus clouds. They're really kind of puffy. You think of electromagnetic clouds, like a layer would be like the clouds that you see. I think that's really what we're looking for, or we're looking at in those, especially in the E layer. Oh, volcanic ash effects. There are, and there's lots, especially when it puts up metal in the air. That actually, you can almost treat it like meteor scatter, because it can definitely cause lots of coupling between the neutral and the charged layers. So, oh yeah, some gorgeous shots of aurora. Here's Oran, Iowa. Okay, so this is one of the lower places that we got it. We saw aurora in all sorts of places. You'll tag me in an image, John? Thank you. That's wonderful. Starlink is 340 miles high. ISS is 254. Not all some Starlinks are 450 kilometers and lower. So, there's some issues, especially with those big solar panels that stick out. They can get some crazy drag. Let's see, anything, what about any other questions, guys? My electric meter ran backwards. Oh my goodness. Not from the solar storm, I can't imagine that. Here is Washington. We had some more gorgeous, we had beautiful aurora even south of Seattle. Here's Plumas, Manitoba. Like I said, Canada always gets gorgeous stuff. Here is Cleveland, Ohio, guys. Can you believe that? So anybody who thinks that we're not getting gorgeous aurora with these things just because I don't post it on YouTube, think again. Here is Bend, Oregon. And there are so many more photographs that I have not been able to post. And if you are an aurora photographer and I have not responded to you, ping me again. I'm being slammed left and right, and I'm really not trying to be, I'm not ignoring you, I promise. It's just a matter of, I just can't get to everybody. Here was Jake, were you in Montana? I thought you were in Wisconsin. MT, yeah. Oh my goodness. Okay, and then there's more Saskatchewan, and I'm going to get kicked out. And then here is Omaha, Nebraska. See that? We even got it in Omaha, Nebraska. So, yeah, you're Cleveland, your hometown. Well, you could have seen it last night. The nice thing, guys, is that if you follow the space weather community on Twitter and you follow this community closely, there will be plenty of more chances, because this G2 level solar storm really wasn't all that spectacular from that point of view. So plenty of more chances to see aurora. And sadly, I have to go. I've got a prior commitment to use the studio. Okay. So thanks for sticking with me. I hope this was a good forecast and solar storm update. And only if you're at high latitude should you even look at aurora or look out for aurora tonight. Okay. So have a good one and go on social media and enjoy. There's lots of pretty pictures. Good night.